Hello everyone. So let us discuss the E problem from the latest Codeforces round 760 problem named Singer's Tour. So I will go through the problem statement first so that it will become more clear to you. The problem statement states that there are n towns that are arranged in a circle sequential manner. The towns are numbered from 1 till n in a clockwise manner. The ith town, there lives a singer which has a repertoire of AI minutes for each 1 to n. It actually just states that there are different singers in every town, and every town there's a singer which has some, what you can say, some record concert, like some music album he has. Ki, I have a music album that is of this much amount, like AI minutes. Okay, now each singer visit all the n towns in a clockwise manner, starting from the town he lives. That is also one important now, that the singer will start from the town he lives and then he will move to the clockwise direction in all the towns visiting that, and gave exactly one concert in each town. That is fine. In addition to each town, the ith singer got inspired in that town and come back with a song that lasts AI minutes. The song was added to his repertoire so that he could perform it in the rest of the cities. It actually means that he, let's say that he perform AI in the first town, then he will perform two of AI because he will add one more AI to his repertoire. So then it will be two of AI, then three of AI, four of AI, and so on. He will add AFI at every like next concert. So you are actually giving the total number of concerts, like the total minutes that is like delivered to a particular town. So all the different singers move to different towns, all the n towns, because they move in a clockwise direction. Every singer will move to every town and they will give the delivery, and you will given that what is the total amount of concert that is heard by that city, and you have to tell that what is the initial repertoire or the total album size or the album minutes of every singer. Let us take one example to even make it more clear. Don't get more afraid, I'll tell you. So it is given 12, 16 and 4. So let us take the example so that it will become more clear to you. Let us take the example. Let us take a city, okay, that is A, B and C, and let's take the direct example that there are, for the first example, there is a valid configuration that is 313. So 3 1 3. Okay, let us take one another pen. It actually means that there is a singer that lives in the A city that has an album or album of size 3, or repertoire of size 3. Then similarly, there's a singer in city B who has an album size of 1, and there's a singer in like city C that has an album of size 3. Now, when this singer like performs in the first city, it will be giving a concert of size 3. Then when this singer, so the total till this point is 3 for the A city. Cool. Now when the singer goes to city B, because it is moving in clockwise direction, it will double the album size or repertoire size. So double means the 2 into 3, that is 6. Then not double, it will add like 3 one more time. So 3 added one more time. Then it will, when go to the next city, 3 is added one more time. So then it is 6, then it will become 9. And then this is like his tour will be completed because now he has given to all the cities. Fine. Now when B will start from the first city because the city from which they started out. So the first city, it will give a concert of size 1. Then when it moves from 1, when it go to the next city, that is clockwise direction, from 1 it will like 1 is added one more time. So as you can see, it just like this number of repertoire is added one more time at every like in every city. So 1 is added one more time, so it will become 2. Then it is 1 added one more time, so it will become 3. Fine. Then C will take the chance, and C will first give it the concert in this city, so the total becomes 3. Then it will go to this city, so 3 is added one more time, so it will become 6. So when it comes to this city, 3 is added one more time, it will become 9. And the total for this city turns out to be, as you can see, 12. For this city, so this is A city, turns out to be 12. For this city, it turns out to be 16. And C city turns out to be 14. So 12, 16, 14. 12, 16, 14. So that is actually the input that is given to you. Fine, that you have understood now. That is given to you, that like if these are the movements of the singers in different cities, the total duration of the concerts that is given to that city is given to you. Now you have to return these numbers, that is 3, 1, 3. Like what is the actual repertoire of each singer. You can pause this video, try to think over that of your own. It's not too much complicated. it might be seeming complicated, but you just directly understand that if when we draw out one example. Okay, let us clear the page. Let us take one more. Okay, so 12, 16, 40. The first observation what you can see here is, let us take or draw it on a number line. Like it will be easy. Like it is in circle also it is easy. But what you can see here is that this is the city A, B and C. Okay. So what you can see is let's generalize and write down some equations so that it will become more clear. It's always beneficial to take some examples. So let's generalize it. So the first singer will be starting from A1, like the first city, giving a total constant of A1. That will become 2A1, then 3A1. The singer B will start from the city B and it will be like A2. Then it go to the next city, that is clockwise direction. So it will be like 2A2. Then it goes clockwise to this city. So it will be 3A2. Got it? Then this city, like this C person, that is A3, starts from this city, clockwise go to this city. So it will be 2A3 and 3A3. Fine. So it means that there's a singer that is having some value or like some repertoire concert value. It is A1, A2, A3 from each cities, and then they have started and doing that. So total concert value heard by each city is like this. This is like in a general format, like general way. Now, one of the things that you can see here is that this is A1, this is A2, that is A3. Okay, that like this is the total of all of them. Like if you just add all of them, like what you can see here is that this is like A1 plus 3A2 plus A3 and so on. But what you can simply see here is that this number is actually like A1. Okay, so if you just add all the numbers, what you can see here is that if you add all the numbers, then like this A1 is actually like taken like 1 time, 2 time, 3 times. So 1 plus 2 plus 3. If you just add all of, like if I'm adding all of them, so actually this A1 plus 3A2 plus 2A3 is actually equal to 12, because this is the total value. Okay, so if I'm just adding all of these values, like all ABC, it means that I'm adding these numbers, and adding all of these numbers, that adding all of these terms. So if I add these terms, let's say if I add these 3 terms, it turns out to be this. If I add these 3 terms, it turns out to be A2 common 1 plus 2 plus 3. If I add these 3 terms, it turns out to be A3 common 1 plus 2 plus 3. If I add all of them, it turns out to be it is A1 plus A2 plus A3 common 1 plus 2 plus 3. And 1 plus 2 plus 3 is actually, like if there are n numbers, it will be n into n plus 1 divided by 2 into A1 plus A2 till an. Got it? So it means that there is some factor out there. When there's some factor, it always, what you can do here is that check that if you just add all of these numbers, it should be a multiple of n into n plus 1 divided by 2. Okay, that is the first check you can directly see and observe. You can do that because the thing that it comes to my mind is because these numbers are actually the summation of all of these numbers. So every number is like adding, like, so it is like in a circle. So circle means that it is 1, 2, 3, 4, 5, 6. So it means that there is a summation of that. So if you just take out some constant factor out of that, and that is a, then it will be like summation of 1, 2, 3, 4, and it is like this only. So I hope you get the point. So just the first thing you can do is that you can just add all of these numbers, and then you just have to check that it should be a multiple of n into n plus 1 divided by 2. If it is not, then the answer is no. That I cannot, like, the configurations that is given to you, the configurations that the total concert time that is given to us, that is false. That is an invalid configuration. So there is no possible answer. Okay. Else, if it is divisible by n into n plus 1 divided by 2, what you can do is that you divide that total sum, the total sum you have, if you divide it by n into n plus 1 divided by 2, what you'll get is that you cancel out this term, because this is the actual sum. This is the total sum. If you divide it by this term, you actually get the total sum of the repertoire of all the people out there. Okay, so I hope you get the point. So if you divide that particular term, like if you have the term that 12, 16, 14, you sum of all of that, it turns out to 42. If you divide it by n into n plus 1 divided by 2, that is equal to 6, it turns out to be 7. And the answer for this actually is also 313 that you can see. So it turns out to be 7 also. So actually, if you do that, if it is a perfect divisible by n into n plus 1 divided by 2, you will get a number that is the summation of all the final answers. Got it? Okay. Now, the next thing what you have to observe is that let us write down the same. So you got one thing right out, that you can directly get the sum of all the final repertoires. Okay, let us directly just write down that thing again. A1, 2A1, 3A1, A2, 2A2, 3A2, A3, 2A3, 3A3. So this is actually the summation of this term, summation of this term, summation of this term. Now, in such type of scenario, you have the sum, or like you have these numbers. Try to subtract out like two terms. If I subtract out, let's say this term and this term, like if I just take, not in numbers, let's do in general case only. If I subtract out, let's say this term and this term, let us see what I get. I have this term that is A1 plus 3A2 plus 2A3. If I subtract out the last term, that is because it is moving clockwise, so from this it will move down to this. That is why I'm subtracting out this term from this term. So 3A1 minus 2A2 minus A3, sorry, it's actually A plus. So then it all become negative, and what you can see here is that this become 2A1. Okay, then it will become plus A2, and then it will become, as you can see, plus A3. Fine. So what you have got till now is that you have got minus 2A, like 2A1, A2 plus A3, and you have also a sum that is A1 plus A2 plus A3. Fine. Now what you can do is that if you take this, like if you take this value that is sum, subtract out this term, let us take this term as t, so s minus t. So the total sum is A1 plus A2 plus A3. If subtract out this term, that is minus of 2 of A1 plus A2 plus A3, this term get cancelled out, this term get cancelled out, and it turns out to be like this, minus will become plus 3A1. Okay, so now I actually got the term. I got A1 finally. So if I had this term and if I subtract out, so if I subtract out the first term with the last term, so I have to subtract out two adjacent terms actually, like so this term with the previous term. So every time you have to subtract out the previous term. So for the first term, the previous term is the last term because it is moving in clockwise direction. So for getting on the first term, you have to get the value for the last term, subtract it from the last term, because I have to get the value for the current term. I have to subtract it from the last term in the cycle, and the last term in the cycle is the clockwise direction. It is the last term. Got it? And thus, what I get is that if I subtract the first term with the last term or the second term with the first term, I will get 3 into A1. 3 means that the total length, that is n, because there are 3 numbers. So n into A1. Again, you find out some factor that is multiplying. Okay, I hope you get the point. So in all of these terms, whenever you find out some number multiplied with factor, you always check that whether the number that you get in the end is a multiple of that number. Hope you get the point. So what I'm doing in the next point is that you will take out the first term subtracted from the last term, that is 12 minus 14, that it turns out to be minus 2. Then what you'll do, you will take minus 2 and you will subtract it from the total sum. Like a total sum that I got is 7. Okay, so what I'll do is 7 minus of minus 2, it turns out to be 8. Okay, so then okay, it turns out to be actually 9. It turns out to be 9. And then what you can see is that 9 is the term that is equivalent to 3 into A1. So the first thing you have to check is that 3 should be a multiple, like this number that is there, that is subtraction of, let's say, A1 minus AN, that is A, let's say 0, 1 and 2. So 8, like A0 minus A2, whatever is the value, it should be a multiple of 3, or that is, or let's say multiple of n. If it is a multiple of n, that is fine. Then the final answer, that is A1, is actually 9 dividing by 3. Like, so the total sum is like this value divided by n, and whatever is the answer, that is 3, like because the answer turns out to be 3, that is the term we want, like the term we actually want. So the first term is actually 3 only, and that is how you can do it this and find out for all the terms. I'll show you the code part, but that's the overall logic for this problem. Hope there can be multiple ways also, but this is one of the ways that is actually easy and understandable, and like you can directly implement that and you can got the idea of that. Okay, let us move down to the solution part for this problem. It's a constructive algorithm, also not too much to go over about. So what you can see here is that what I've done here is that first thing is ki take the input of all the numbers, find out the sum of the numbers, because the first check is that the total sum should be a multiple of n into n into n plus 1 divided by 2. So total sum. If it is not a multiple, then you just return like no, that this is not a valid configuration. If it is a valid configuration, divide total by sum, that the totals like sum is n into n plus 1 divided by 2 divided by total. So that total now I have is the total sum of all the repertoires, or the total sum of all the concert values, like the album values, sorry. Then I will iterate over for all the numbers from 1 till n and subtract out the divisible, like find out the like the difference from the current number and the previous number. So because in the previous number, for the first number I will have to go one step back. What I'll do is like I'll take the last number like and and add I to it, like because I means that I'm starting from the last number and then I add I to it, that is like 0, 1, 2. And because after that I can overflow, I will like round it off to like mod it with n, so that I will come to the first position. It just means that I'm starting from the last position and then I go to the next position, and because I'm rounding out, I will come to the first position. Nothing much different. Finding out the difference, and finding out difference, I have to subtract it from s now, so that I will get n into the ai value that I want. So it should not be negative. It turns out it should not be negative. It should be a positive value that is given the problem. Also, it should be a multiple of n. If both of these conditions are true, then only I've got the answer. If any of these conditions got out to be false, then the answer is no. This configuration is also not valid. If I got a correct answer, then the difference divided by n is actually the answer. So the difference divided by n is the correct answer. So store that in some answer vector, and in the end print out yes and print out the answer. Hope you get the solution part and the logical part for this video. If you are with me at the end of this video, thank you for watching this video till the end. I will see you next one. Till then, keep coding and bye.